here's my code for the Mazebot. At the top, we just have the new liquid crystal common code that I just copied and pasted from our previous lab. I think it was 6. So here we have our servo motors, just declaring the servo motors. We are setting our push button as integer, and this maze complete integer will actually come in at the end. It'll just tell my robot basically to stop. So here we are assigning my motors, or my servo motors actually, to their pins and setting their min and maxes. Just setting up the input pull up and setting the push button to pin 2. So we have the LCD set up. This is just setting the backlight pin and allowing that to light up. And here's our just basic print that we want the LCD to show. So here we go into our loop, which allows the Mazebot to do its course. So we want the Mazebot to read the push button and see its value. So it'll start after a delay of 1000, which is I think 5 seconds. So this while loop is to move the bot forward until the button is pressed. So for my motor right, what I found my issue was the right motor was actually in reverse. Not sure how that happened, but I had to switch all my numbers around. So for my left motor, 60 should be forward, and I should have 60 for the right motor, but I had to change that to 120 so I could get it going in both in the right direction. But after that, it goes forward, and then the button is pushed in, and then it has the value right here. So once the button is pushed, ends the while loop, and it'll stop. And then LCD will say wall detected. 90 is off for the servos. And then we go down here. Once it hits the wall, it'll reverse from the wall. I had to flip these, my left servo, my right servo around to get it to reverse correctly. These set cursors are just setting the pin where we want our wording to display. That's just setting the location on the LCD. So we reverse, and then we stop after we reverse, and then the Mazebot will turn left, and it'll display turning left with a little delay. And then after it turns left, the Mazebot will stop, and then it'll go back into another while loop. So I use the while loops to keep it going forward until the button is pushed in. So it'll evaluate and do a digital read on the push button at the end of the while loop. And then once it realizes that the button is pushed, it'll just go back to doing the commands again, which are basically the same commands I had before. So they're all the same until we get down to this turning right, because it only makes one left turn and the rest are all right turns. So I had to play around with these numbers a little bit to get it to turn at a 90 degree. It kept going a little too far and not far enough sometimes, so I had to work those numbers out. But once I got it, it was running pretty good. And another while loop for it to go over the ramp. Same here, after the ramp, it'll detect the wall, stop, go in reverse, stop again, then it'll turn right and head for the last wall. And once it turns right, it'll stop, and then I put another while loop for it to go forward to the last wall. It'll hit the last wall, go into reverse again, it'll stop, and then it'll make a 180 degree turn, and then it'll display maze complete. So to get the Mazebot to actually stop, I just put a while loop and just say maze is complete when it equals 1, and then I just put both of the servos set at 90, which is actually turning them off to 0. After just seeing some pictures of my robot design. Here's a little video of it. So we have 2 servos on the bottom. One is going to give power to the left side of the wheels with this 60 teeth big gear. So it's going to be called the driving gear, which is actually going to drive these 2 40 teeth gears, which are actually attached to the wheels. The big one drives the small gears, and the small gears drive the wheels. And same thing on the right side. And we have this push button in the front, which is actually going to detect the walls for objective 2, and it's going to provide feedback to the Arduino Mega. Turn that on, we have power, and both of our motors. There are 2-pin motors, so we had to put these motor controllers on because the Mega has 3 pins, and without having the 3 pins in there, it's not going to read stuff correctly. So we had to put the motor controllers on both sides for it to work. And here I have my battery, secure the battery in there. I just used this little piece of metal, and it was already sort of bent like this, so I just attached it down there with 2 screws. And I have this little double layer thing on both sides, and have the Mega attached on both of them. And then other than that, it all went pretty smoothly. Now it's time for my video on troubleshooting. So one of the main issues I actually had was the first time I assembled it, this shaft that goes into the servo, it didn't actually go all the way into the motor. Me thinking that it did, I assembled it all together and everything, thought there was no issues, and when I put power to the servo, this shaft was just free spinning. The servo was free spinning, and the shaft wasn't moving at all, causing the gears not to move or anything. So I had to take apart this whole side, take the shaft out, and I actually had to file the end down because it had like just a tiny piece of it that was like snagged, I guess. It wasn't like a clean cut, so I had to file that off, and I could jam it in there, and then it worked perfectly fine after that. And then another issue I had was my right servo. When I set it the same as my left in the forward motion, this one actually turned backwards and this one turned forward. So in the code, I had to switch it all around and everything to get the numbers right. And I had to just tape these together. I took the tape off now, but I had to tape these together because they kept coming undone, and I had to wrap them around here. But other than that, it wasn't too bad.